Okay there, algebra students. This is part 2 of 9.5b, solving quadratic equations using the quadratic formula. The number y of northern Rocky Mountain, wolf breeding pairs. So y northern Rocky Mountain wolf breeding pairs, okay? X years since 1990. So it sounds like we're doing some kind of animal wildlife study here, which is pretty cool. And it can be modeled by Y, which represents the wolf breeding pairs, number of Y wolf breeding pairs, and is equal to, let's see, 2/10 or 20/100 X squared. That means that many years since 1990 plus 1.8 times that many years since 1990 minus 3. When were there about 35 breeding pairs? You know, one of the hardest things in math is organizing what your variables represent. If Y represents the breeding pairs and X represents the years, are we going to substitute 35 in for Y or X? I really hope that you're all saying Y, because it's the Y that represents the wolf breeding pair. So I'm going to do that over here, try to save myself as much space as possible, unlike the last problem where I didn't show very nice work. So 35 is equal to 0 and I guess 20/100 X squared plus 1 and 8/10 X minus 3. Okay. When the question says when, it's asking for a time, like when will that happen? And of course, X representing the number of years since 1990, it makes sense that we want to know what X is because that'll tell us how many years it has been. And then we'll use this graph, which has already been made, just to verify that we have the correct value for X. Okay, can we solve this? Well, yes, we have two methods essentially right now. Well, there's actually three using completing the square, but we're not going to do completing the square. Right now, we're going to think about this in terms of doing the zero product property. So I would want to get 0 on the left side by subtracting 35. But the problem is then I would have to factor this thing, and it has decimals. And that makes it really hard. So in that case, the better choice is the quadratic formula. So if I subtract 35 from both sides, I get 0 is equal to 0 and 20/100 X squared. Oh, look at that. I used the little dot. That was really good. Plus 1.8X. And then we subtracted 35, so that's negative 38. Okay? Now we have a quadratic equation, right? Because I have ax squared plus bx plus c equals 0 over here. If I have a quadratic equation, I can try solving this using the quadratic formula. So I'm going to start writing the quadratic formula here, and then I'll continue down this column so I have as much space as possible. So x, well, wait, before I start, my bad. Let me identify A is 0 and 2/10. Is anybody gonna get mad if I ditch that 0 and just put 0 and 2/10 instead of, okay, fine, thank you. B is equal to positive 1 and 8/10, or yeah, 8/10. And then finally C is equal to negative 38. Perfect. Now we're going to substitute in our values. So x is equal to negative b, negative 1.8 plus or minus square root of b squared. Okay, b squared. I'm going to get out a calculator and do that now. So just get that over with right now. B squared, that means you'd have two factors of 1.8. So 1.8 times 1.8. And that's 3 and 24/100. So I'm going to write 3 and 24/100 in right here. Whoa. There we go. Minus 4 times, and then A is 2/10. And C is negative 38. And then you're going to divide that by 2 times A, and 2 times A is 0 and 4/10. Cool. Okay, I'm just going to keep that calculator handy, and I'm going to go ahead and write this, the next, as if I kept on moving down. I'm going to go whoa, whoa, whoa with a little arrow. As I said before, my favorite way to evaluate this, and you don't have to follow what I'm doing, is to, some of you are like, oh, my favorite way is using Slater, is to first deal with the discriminant, everything that's underneath that square root, and leave everything else alone. So this is 3 and 24/100 minus, okay, 4 times 0.2 times -38. Well, I like doing the sign first. This is technically -4 times positive 2/10 times negative. Negative times a positive negative times a negative is a positive. So I'm going to put a plus in there to begin with. And the 3 and 24/100, that's just going to wait. It's just going to wait till it has, there we go. Okay, now I'm going to use my calculator, even though I could probably do that in my head. Okay, let's clear this first. 4 times 2/10 times 38. We've already taken care of the sign. I always say sign first, then number, sign first, then number. I say it like 1,000 times in my Math 6 class. Math 6 Accelerated, whatever it is. 30.4. I always have to extend. I never make those things long enough, but there you go. Okay, so now just make this a little simpler. I don't have to write x over here every single time. I know it's going to be x, but we're just going to, I guess we'll keep this -1 and 8/10 plus or minus square root, and then over 4/10. Okay, so now I'm going to take that 30 and 4/10. I'm just going to add 3 and 24/100. I get 33 and 64/100, which to me is not obviously a perfect square or anything. Okay, so at this juncture, I can write 2 different equations, right? Because the plus or minus means there's going to be 2 different equations. So the first one, I'm going to do x equals -1.8 plus, well, I guess we'll do a plus, right? And I need to take the square root of this, 33.64, and it's 5.8. So plus 5.8 divided by 0 and 4/10. Okay, I'm going from 0, left 1.8, but I'm going right to 5, right 5.8. So I'm going further to the right, so I should get a positive, right? And they're opposite signs, so I subtract the absolute values. So 5.8 minus 1.8 equals 4. And what am I going to divide that by? 0.4. So hopefully you actually already know what that is. It's 10. So I get x equals 10. That's one of my solutions. But don't get too excited yet, because we still have to do the other one. X equals -1 and 8/10 minus, but we already did the square root of this 33.64. It's 5.8 all over 0 and 4/10. This time, in the numerator, I'm going left 1 and 8/10 from 0, and then left further 5 and 8/10. So I'm going to end up in the negatives, right? So I'm going to end up in the negatives, and I'm going to add the absolute values because you're going away from 0 both times. So that's 1.8 plus 5.8, right? So -7.6 divided by 0.4, -19. So x equals -19. Okay. Get rid of this. Okay, what does x represent again? It represents the year since 1990. Which one of our 2 solutions can we reject? This x equals -19, we're not going to use that. That's not definitely not one of our solutions, because that's as if we were going back in time since 1990. So the real answer here, when were there about 35 breeding pairs? There were 35 breeding pairs. I can't write that in here. I'm not going to mess that up. 10 years after 1990, 10 years after 1990, or year 2000. Jeez, doing a Y is one of the harder things in life. 10 years after 1990. Yes, that's just 2000. Let's see if that makes sense. 35 number of breeding pairs, that's our Y. It's about here, and yeah, that's about 10, somewhere in that region. So essentially this graph seems to agree with what we have determined the amount of time after should be.